All right, so now that we have our problem well posed, let's try to calculate what that resultant force is. The resultant force is simply, the pressure integrated over the area, and the pressure goes as rho gh, so the total integral is rho gh times dA. H can be defined using the xi coordinate system measured from the top interface, so that's rho g times xi sine theta dA. And then we can pull a bunch of that stuff outside the integral because it actually doesn't depend on the area or the infinitesimal element of area. So we actually only need to integrate xi over dA. And we can split xi into the portion that's measured towards the center of gravity and then the other coordinate system that has like the y and x axis. So in total, xi is just the center of gravity minus y if you look at the way the coordinate system is defined. So we can actually, there's two terms in the integral, we can break them apart and do them separately. The first one doesn't actually have anything to integrate, right? Because psi sub cg is a constant. So the first term is just psi sub cg times a. And the second one ends up being an integral of y about dA, but recall that y is measured relative to the centroid. And so by definition, the integral of y dA is 0 if y is measured about the centroid. So we can put that all together. So the final result for the resultant force is rho times g times the distance to the centroid, psi sub cg times sine theta, times the area. But psi sub cg times sine theta, what's that? That's actually the depth at the centroid. And so the final result is that you can calculate the resultant force very, very easily by just taking rho gh, where h is the depth at the centroid of the submerged object times the total area of the object.